Hello, welcome to Fintech Impact. I'm your host, Jason Pereira. Today's show, I have Ethan Buckman, co-founder of Cosmos and CEO of Informal Systems. Cosmos is one of the largest blockchains and most valuable cryptocurrencies in the world, and Ethan was an integral part of helping create that. And with that, here's my interview with Ethan. Hello, Ethan.
Hey, Jason. Good to be here.
Good to have you. So, Ethan Buckman, co-founder of Cosmos and currently of Informal Systems. Tell us about Cosmos.
Cool. So Cosmos is in the world of blockchains and cryptocurrencies. We're sort of thinking about the space as if it's very early days of the internet, where people are trying to figure out what kind of infrastructure makes sense, what kind of protocols make sense. There's different battles at different layers of the stack. What ultimately won out in the internet was the idea that we would have sovereign independent computers, independently owned and operated by whoever wanted to, running arbitrary applications on arbitrary hardware. And all of these different sovereign heterogeneous computers would interoperate with one another using a common communications protocol, essentially TCP/IP as we know it today. And so Cosmos is very much about taking that same kind of approach of sovereignty, heterogeneity, and interoperability and applying it to the blockchain space. So today we have many different blockchains existing. They're all trying to figure out which kind of technology stack to use and how to architect themselves. A number of them position themselves as like the be-all, end-all blockchain, the only blockchain the world will ever need kind of thing, which I think you can think about a lot like saying, 30 years ago that we only need one mainframe and that'll do all of the world's computing and no one else needs a computer. So Cosmos is kind of coming into that space and saying, look, we want to make it as easy as possible for people to build their own blockchains, launch their own blockchains, structure them in the ways that they need to, that fit their needs and fit their values and the values of their community, to provide as much flexibility to the developers to be able to do that and to still enable those many different blockchains to interoperate with one another. And that's really the vision and goal and mission of Cosmos.
Yeah, it's funny. And if you think back to that debate and what probably went down was you try to build something by consensus, it's never going to happen, right? So you had everybody wanted to do their own thing. And I'm sure that at some point someone said something great. Finally, let's just all shut up and just everybody do their own thing, but we'll figure out how to communicate with each other, which wasn't like the core value proposition that they were all after, right? They were all doing their own thing. Communication was secondary. So it was easier to land on a standard than, it's not like that's not how it happened at all, but it was easier to come to a satisfying standard at a time to deal with something that they cared about, but not to the nth degree than it is for something that gets as passionately debated as the blockchain sphere. So before we jump into how you execute on how Cosmos executes and how it compares to others and other things like that, let's get into, first and foremost, your history. So tell me about your history and how you came to be a part of this project and where you got to where you are now.
So the history, I guess, goes back to 2013 when I first really sunk my teeth into Bitcoin. In the summer of 2013, I programmed my first Bitcoin transaction from scratch, which was kind of unbelievable. It's almost like a religious experience to be able to do that.
I was going to say, it was love at first sight, right? You're just like, the world has changed.
I mean, for an economic structure, a financial system to be that open that a programmer can, from scratch, in a common programming language, with no permission or without paying a fee to anyone, in a couple of days, program enough to actually submit a fully valid transaction into the network that moves essentially an arbitrary amount of money, was just really enlightening and felt incredible. And so I was pretty much, sunk into it from there. I guess before that, and the things that got me interested in Bitcoin, I studied biophysics and in particular the physics of the organism. And so I was infatuated with the idea of organisms as emergent phenomena, with ideas around sustainability, what makes organisms so much more sustainable than the systems that humans design, and how can we sort of bridge that gap to build human systems that function more like organisms rather than, say, tornadoes. And I think a lot of the structures we build in our financial system and our political systems, they resemble a lot more a tornado than they do a forest or, a toad or a mushroom or whatever. And so that was really where I was coming from. And I sort of saw Bitcoin as the first example of an organism emerging in this new digital environment. So I was used to studying them in the biophysical environment, and here was this organism that seemed to be emerging in the digital environment, and that seemed really important. And so I got pretty hooked on that because it seemed like digital technologies and tools were going to play a big role in building more sustainable systems. And here was kind of the first one emerging, wasn't top-down controlled, no one owned it, it sort of operated on its own, very difficult to kill it. It had elements of sustainability from another perspective. Obviously, Bitcoin is heavily unsustainable because of the proof of work, but that's a separate topic we can get into. And so I was really hooked on that. But the intuition I started building on what the blockchain space was and what it meant was that this was really the next logical evolution in the history of automating human processes, right? So we started with individual computers. People started moving their processes onto their computers, their spreadsheets, and so on. And then we started moving into the cloud and this more distributed environment and the world of, say, someone else's computer or Jeff Bezos's computer. And now everyone's running their thing off premise on the cloud. And I think the next phase of that is really the multi-stakeholder operation. So having a digital process that runs across multiple stakeholders, because still a lot of the things we run on the cloud, they're the processes of a single business, a single organization, right? That runs their particular infrastructure on the cloud. But more and more in our, globalized environment and the access to business operations is so much more accessible and people are trying to do more and more interesting things, it becomes increasingly important to run robust, fault-tolerant business operations across multiple businesses or multiple stakeholders. And it's difficult to do that with sort of existing technologies. And so I sort of saw the blockchain's technology as really that next step in the automation of human processes, but where we're now moving into the multi-stakeholder domain. So automating multi-stakeholder processes. And I was really hooked on that.
And in fairness, I mean, the systems were never designed to be distributed, right? Like there was always this, like, whether it be the cost constraint or the security concerns, whatever it would be, they were always designed to simply sit in one place, right? And it's interesting, your conversation about the organic versus inorganic systems, and I'm going to butcher this. What's that principle about any inherently complex system had to have been born from a series of expansion of simple systems? Because when you inherently build a complex system to start, it fails. And too often, a lot of what fails in our systems is that it's a layering of complexity on complexity when the complexity was not secure like a simple system is. Anyway, there's my philosophical rant for the day. But so you're right. So this is, again, paradigm shifting in so many ways. Please continue.
Sure. Yeah. So I think that's spot on. And that perspective certainly influenced how we designed Cosmos, and what makes it different from a lot of the other blockchain solutions was sort of trying to figure it all out up front. So yeah, sometime around 2014, I found Ethereum very early. It was sort of spawned in Toronto, and I was in Toronto. And so we were going to the Ethereum meetups and we're getting involved and started helping out a little bit with the development even. So, we're very early Ethereum contributors. And I joined a company that year that was working on trying to basically, it was founded by lawyers who saw the foundational opportunity here that Ethereum and the smart contract environment and basically automatic execution of contract could offer to businesses and to business process automation. They tried to capitalize on that. And so early on, we were trying to take the Ethereum virtual machine, the Ethereum programming environment, and bring it to businesses, right? And to do that, you couldn't use the entire Ethereum stack, because at the bottom of the Ethereum stack was this notion that you were running in a public adversarial environment and that used this proof of work consensus mechanism thing, which required a lot of energy expenditure and didn't really make much sense in a sort of more private or business environment. And so what I was working on back then was really finding an alternative to that. And at the time, people had started talking about proof of stake, this idea of an alternative to proof of work, where instead of participation being based on essentially wasted computational power, participation would be based on having some stake in the network, right? Having some coins bonded in some way. And so there was a big movement in 2014 to start to unravel how this proof of stake sort of thing could compare to proof of work, how it could be secure. There are many it's a different sort of security model, so you have to work through a lot of subtleties. But we really convinced ourselves that proof of stake was the future, and that if we were going to have a world with many hundreds, thousands, millions of blockchains, which we started to believe was coming, that we would need to build a robust proof of stake infrastructure to support that.
So let's take a step back there, and just for the non-crypto junkies listening, let's make sure we're clear on this. So proof of work, basically the kind of defining factor of whether or not you were part of this network or whether you got rewarded with coins, was the fact that you lent computing cycles towards doing the calculations to create the blocks.
That's right.
And basically that cycle would then be rewarded by Bitcoin at first, or whatever coins it was. So you did the work, here you go, thanks. So the proof of work was what kept people vested in being in a network.
That's right.
Proof of stake shifts that from being, I'm not going to necessarily, that's not the valuable aspect of this. It's I own coins in this infrastructure because I use that to implement or support the underlying activity that's being done by this chain. So the way to look at this is that if you want to transact a contract with another person and you're the lawyer in the middle, you're going to need a coin. There's going to be a tokenization of that. And you need to be able to have that quote unquote currency in order to facilitate that transaction, as opposed to just the computing cycle, which is, I haven't looked at charts on what the total power consumption of the Bitcoin blockchain is right now, but I'm sure if I did, I would be frightened. But yeah, far more
greater
efficient
than small nations is the way people put it. So,
I really hope it's renewable power. That's all I'm saying.
Well, I mean, it's interesting. I mean, we could go down this rabbit hole. I call myself a closet Bitcoin maximalist, because I have been like leading the charge on proof of stake since 2014 and devote all my time to building proof of stake solutions and making that the future. And yet I am I will argue to the ends of the earth that Bitcoin is actually not as unsustainable as people think, and it might actually be pushing the bar on renewable energy use and on making computers more energy efficient and a number of other things. So, but maybe that's for.
Oh yeah, I mean it's interesting because it is the use case. It is providing the incentive for cheap, affordable power and efficiency in computational data, right? I mean, unfortunately, looking at 2019 statistics are a little bit frightening. Bitcoin consumed more power than Switzerland.
Small nation.
Yeah. Switzerland, Greece, Ireland, and Israel were all less than Bitcoin. That was last year. I don't know where it is this year.
Right.
Whew. But yeah, you're right. I mean, like at the same time, like we said, they've got the same issues that everybody else does. If power is expensive, it just becomes a non-viable non-viable to actually mine these things. I mean, we've heard the stories about people getting illegal feeds from Chinese dams or nuclear plants or whatever it is, but that's the exception, not the rule. Yeah. Anyway, that's an interesting sidetrack. And as for the sustainability of Bitcoin, I largely agree with you in that beyond the power consumption, just because when you look at the number of endpoint nodes and the number of use cases for it, the ecosystem is more robustly built up around Bitcoin than any other one single protocol. So if you want to talk about transacting in a cryptocurrency, regardless of what you think of volatility, and you're looking to have the maximum amount of impact or the maximum amount of options, where else do you go?
Well, I mean, to be honest, the Ethereum ecosystem is booming. And if you want to build an interesting application using kind of the benefiting from the guarantees you get from the blockchain tech in a public economic setting, like the singular Ethereum blockchain is wonderful for that and getting a lot better. Now, obviously, it has tons of flaws and it's always sort of been a toy, in my opinion, a toy programming environment. And yet we've built this, multi-billion-dollar production scenario around it, which is incredibly frightening. And, I've sort of made it my own personal motto to write as little public Ethereum code as possible, holding real money, because it's so frightening. But it is getting really interesting what you can do there for sure. But I think that to some extent, the model of like this single large public blockchain that you have with Ethereum is again sort of like the idea of having a single large mainframe back in the 80s for like everyone's computing for the rest of time, right?
Yeah, there are use cases for it, but absolutely the need for private blockchain. This is not a purist argument. The need for blockchain is immense, right? Because at the end of the day, if we're going to talk about parametric contracts and transacting in any number of and smart contracts in any number of ways, some of this stuff is not public record and shouldn't be public record. I don't want people knowing every bit of business I do, right? Yeah. Like you want to talk about putting together a public registry that replaces custodians of stock exchanges with basically a blockchain. It's more efficient. I'm game for that. You want to make every aspect of every contract I enter into my life publicly searchable. I'm out.
Right. So I think, there's a number of dimensions here, and one of them is certainly the public-private dimension. And obviously, if you want private blockchains, then you need solutions for that. But I think there also is a broad role for many public blockchains. And with the advances that are coming and here to some extent in cryptography, there's more and more that you can actually host on a public blockchain without revealing the underlying data. So the public blockchain becomes this like source of truth that you can audit against without necessarily revealing all the information to the whole world. So the boundary between public and private becomes significantly blurred. But I think if there's more, I have this sort of take where if all we get out of blockchains is like slightly more efficient financial markets on slightly more transparent.
Hey, I'm just mentioning things that are close to home to my day job. Okay? That's all I'm saying.
I'm just saying,
And honestly, that's low hanging fruit, right?
Like that's low hanging fruit.
Yeah, it's not that big.
A lot of people are distracted with that, right? And the reality is, going back to the sustainability question, like our existing financial system and our existing like economic structures are so fundamentally unsustainable that it's almost comical. And it's this like massive elephant in the room that we're all trying to ignore. And we talk about the sustainability of the planet and all these other things, but the financial structure is very, very fragile and somewhat terrifying. And we're going to see some of the fallout from that. In these post-COVID days, as tourism's collapsing across the world this summer. We'll see what that does to people. But my hope and the reason I work on this technology is because I think it will facilitate more bottom-up, localist-based approaches to rebuilding the economic system and to finding a way not to overthrow or to replace the existing financial system, but to find a way to ground it in a more sort of bottom-up reality where you have many blockchains we call them blockchains because that's just what the technology is, but many of these kind of more local economic structures that are more consensus-driven, more transparent, but in a sort of bottom-up way that provide this sort of local sovereignty so the local community can sort of own it. It's not this like foreign Federal Reserve thing that you have no control over or whatever. And it can be heterogeneous in the sense that it's like adapted to the needs of the local community and representing its local supply chains and so on. and yet still interoperable with the many other blockchains of neighboring jurisdictions, of encompassing jurisdictions, and so on. So that kind of vision is really what motivated a lot of the designs in philosophy and Cosmos and what we're still working towards.
It makes a lot of sense. I mean, I've had a lot of discussions about community-based coins and how basically, that encourages commerce within said community as a valuable metric, or even concepts of around giving back within your community. Like, someone's painting their garage and needs help or something like that. You can volunteer time in exchange for the coin, which could then be exchanged for goods, services, or whatever else, right?
Yep.
There's an nth degree of this. I mean, and I'm glad we had this discussion previously. You're not one of the anarchists in this space, thankfully. When I hear people's compelling argument is that I want to pay taxes, it's just like, okay, stop. Like you're not. I know your motivation is not to pay taxes. I don't think you understand government's motivations to make you pay taxes. One way or another, you're paying taxes, and
taxes will be paid. Yeah.
Exactly. Taxes will be paid. In fact, taxes will be paid more efficiently with far less burden than currently is the system in a lot of places, right? Assuming we can roll this out properly. So, okay, so we talked to what Cosmos is, which is again a kind of we'll term it the generation. Like, I don't know if this is fully there, that the language is there, but I mean, like, we can consider Bitcoin the first generation of blockchain, and then Ethereum kind of a second, kind of a third gen, next stage kind of iteration, more flexible, learn from the past. Tell me where the limitations are in Ethereum, for instance, without beating it up too much, and how you solve for that besides the public-private issue, right? Like that's an obvious one, right? You want to have a private blockchain? Yeah, well, you're not really using the full ecosystem in Ethereum.
Yeah, so there's a number of things wrong. So one is, don't get me wrong, I love Ethereum. I love what it has done for the ecosystem, and I worked on it myself, and I still hold Ether. So full disclosure, but I do rag on it quite a bit.
It's like on CNBC when the what do you call it? The analyst has to disclose whether or not he holds positions in the stock he's commenting on. So that's perfect.
Exactly.
There we go.
Yeah. So some of the problems with Ethereum are, first of all, the programming environment, it's not safe. So the environment is secure in the sense that it's deterministic, and the blockchain provides these very strong guarantees of like immutability and so on. But the virtual machine there and the language around it, it's very difficult to actually write code in that doesn't behave in unexpected ways. So there are a lot of surprises and things you have to know about. And so actually writing safe code that isn't going to lose money or isn't going to be hacked in weird ways is very challenging, just because of the design and sort of the way security was thought of in the design of that environment. Was in one particular way and not in another, right? And that has sort of made it very difficult. And we see that all the time, and we saw it most famously with the DAO in 2016, and more recently certain multi-sigs and other kind of issues where even some of the best programmers in this domain, some of the best Solidity writers, some of the people who helped engineer the language and the whole system, it's still challenging for them to write safe Ethereum smart contracts, right? And that's partially because of the surface area. You have this Turing complete virtual machine. It can do anything. There's a lot of interacting components, and it's very hard to reason through the correctness of your smart contract, or especially a system of smart contracts when you have many of them interacting, right? And I think that's a big deterrent to actually building secure software. Now, that said, there has been an emergence. On the one hand, it's bad. On the other hand, it's done tremendous things for the world of formal verification. So for the first time, this sort of domain of computer science that's focused on mathematically proving that code does what you want it to, beyond just like writing some tests, but really like having a mathematical proof, has become a huge industry in some sense, because now anyone who's deploying a smart contract knows that they're obliged to basically have it formally verified, right? And so now you have a number of businesses that have sprung up to start doing that sort of work and for formal verification of smart contracts, and that's awesome. But at the same time, the environment is still sort of difficult to program against. It's a weird, esoteric language. It's not a language you're used to. It's not, Go or Rust or Python. It's this new thing. And then the other thing you have to reckon with is that typically when people are talking about programming on Ethereum, they're talking about the singular public Ethereum blockchain, right? Which is a single blockchain, runs on proof of work. It's powered by fees, right? So you have to pay fees to execute. And even though you may build your own tokens and so on top of it, the price of Ether still makes a big difference to how expensive it is to use that platform, right? And all of the apps running on that platform are competing for the same resources. And so basically the thing in its current form isn't scalable in any sense. So if you want to deploy an application that's going to have even hundreds or thousands of users that are operating very regularly with the system, you can cripple the system, right? In terms of its bandwidth, and suddenly things become throttled, and now accessing it becomes a lot more expensive. You have to pay higher fees. And we've seen this a few times over, where suddenly an application gets a lot of popularity, and now there's a huge influx of transactions on Ethereum, and all the fees go up. In some sense, the system is working, but it's bottlenecked. So sort of related to this, and the fact that it's all on a single chain, is the governance issues. And because the public Ethereum blockchain is continuing to evolve and continuing to upgrade in a way that is under, say, it's not really under any particular entity or institution. There's this very informal governance. I don't know what to call it because it's not an institution in a formal sense. It's this, amorphous, decentralized institutional form that is trying to govern this public blockchain that no one is effectively in charge of, that upgrades in ways that meet whatever this consensus is, that may not be relevant or maybe explicitly adversarial to your needs as a developer of a particular app, right? And so we've seen this happen where Ethereum goes through a major upgrade and it just breaks all the contracts of a particular application, particular developer, right? And that's something that, imagine every year or something, like AWS just completely broke all of its APIs and suddenly all of your production infrastructure is now broken and you have to spend a few months fixing it, right? So that's
that, and the number of heart attacks that would occur in the valley would be astonishing. Like, yeah, you're never in a good place when someone shifts the entire underlying foundation of your building while you're in it. Like it's not good.
Exactly. So those are a number of the issues. And then there's the scalability issue, right? Well, we sort of mentioned that. And so Cosmos was really sort of trying to address, we sort of came up with the idea in 2016 really formally and wrote that white paper, but it was really trying to address these issues we were seeing in the existing cryptocurrency space of these throughput bottlenecks, of speed, of security with proof of work, of scalability, of flexibility, of the development environment, of sovereignty for the developer, and so on, right? And really what we came up with was prioritizing especially these values of sovereignty, heterogeneity, and interoperability so that any community could build their own blockchain easily using programming languages that they were already comfortable with, that already had professional tool chains and testing stories and so on. They could even take existing applications that they had already built in a non-blockchain environment and wrap them up in a small interface and suddenly run them in a distributed fault-tolerant blockchain environment and be able to do that in a way that was still going to be, that would be under their control or the control of their community, however they defined it, and yet still interoperable with the larger set of other blockchains and other networks, other public, blockchain networks and so on. And we're starting to see that vision actually come to life. Over the last year, we've seen a number of Cosmos-based blockchains launch. There's about 5 of them that are all built with kind of a common technology stack and this common set of values. One of them, what we call the Cosmos Hub, is the one that supports the Atom token. So that's often that's what people will think of as Cosmos. But the reality is, like, what Cosmos is more of a philosophy of building blockchains than any particular blockchain or particular network or particular thing, right? It's like trying to look at the internet and say, well, which one of these things is the internet? Is it Google? Is it Facebook? Is it this podcast, right? It's all of these things together.
They're all the internets, yep.
Common protocols, right? And so that's really what Cosmos is trying to do. And a few of the existing blockchains built within that stack and within that infrastructure are what some people will refer to as Cosmos today. But what that is, it kind of grows over time. What we're really hoping for is that we start to see governments and communities and real world actual businesses start to look at, like, what is my local supply chain? What are the local economic engagements that I have? How could the infrastructure, my financial infrastructure and so on, better reflect this? And how could we come together, a set of us come together to launch one of these blockchains that is governed by us in a way defined by us using technologies that we want to support our local economics, but that's also interoperable, of course, with the rest of the world. And that's really what we're working on.
Fantastic. It's a tall order. I mean, and so much what you're talking about is actually the promise of blockchain in general, is the entire ability to do that. And like so many other things, the first version of something is not perfect. The second version of something is not perfect. The third one's not perfect, but you come a long way and
it's getting there. Yeah.
Yeah, exactly. Yeah. Right. There is no perfect code, right?
Of course not,
but the reality is that, every successive generation builds on stands on the shoulders of giants and gets a little bit further to the sky. So you're doing that. And it's interesting too, because we're finally starting to see the delivery of so much of what was promise and potential that frankly, I'm glad to see it, because I'm so tired of hearing people like, oh, it could do all this. That's nice. Let me see it do it.
Back in 2014, when we started thinking about these ideas and about proof of stake, and there was nothing really in production then, or people were just starting to figure out how to secure it. And we sort of sketched out what the next 5-10 years was going to look like in development and what would have to be built and so on. 5 years later, all of that stuff has started to go into production, and we're seeing all these new proof of stake blockchains launch. So it's really amazing to actually see that coming, and then, to go, what's the next 5-10 years? And it's all about the interoperability and actually using this stuff in the real world for real applications and for ideally more than just finance and, stock markets and so on. Yeah.
Again, it's one of these things that's paradigm changing, right? And I've often said, like, we use the term coin because, frankly, that was the corollary we were able to draw, right? And it was originally started as a financial thing in the first place. But in actuality, we're just basically using old language to explain new paradigms. And it's not unusual that the closest thing that the old paradigm resembles to the new paradigm, that's the first application of the new paradigm. Totally makes sense. But when you start getting into things like you talked about, supply chain, parametric contract, parametric insurance, like, any number of things, I'm still staying in the realm of finance there, but just fundamentally changing the operability of how contracts work, and just the audit system, the amount of time it takes to get things invigilated, and paid. It's the potential goes through the roof. When you think about the efficiency gains, it's staggering. But like I said, it's nice to see these things starting to come to fruition because there's an old saying. It's what is it? It's amateurs talk about strategy, professionals talk about logistics. And I got very tired about hearing people talk about strategy and not logistics for a long time. Now I'm starting to see logistics come to light. So let's talk about, Cosmos, we've hit that note really well. Let's talk about what you're doing with Informal Systems. What does Informal Systems do, and specifically in relation to Cosmos and the blockchain?
Sure. So over the last few years, we've built this Cosmos technology stack. We put it into production. It's supporting billions of dollars in value across the different blockchains that are running it. At the bottom of that stack is a system called Tendermint, which is essentially the consensus and networking layer. And so that's really where all the protocol that enables agreement between many different parties over the internet. And that's a very, very low level piece of software. It was sort of a pioneer in the sense that it pushed the boundary on what consensus systems could do. I mean, consensus systems have been run in production for decades, and every major internet service at the bottom of the stack, there's something that has to keep computers in agreement in a fault tolerant way. And Tendermint was really the first to do that on the public internet in a way that was able to tolerate really adversarial faults with hundreds of participants. And that's what powers the Cosmos blockchains today. But in sort of building and designing that Tendermint software, it's an unbelievably difficult and error-prone process, right? And it's shocking that it works as well as it does. And every day that goes by and these systems are still running in production is just like amazing testament to the just like overwhelming manual effort that went into reading the code and verifying it by hand and so on. So sort of coming out of that process and that experience and that learning, and looking at where computer science has gone in the meantime in terms of formal verification and being able to better verify the correctness of code using sort of tooling and mathematics that are maybe less error prone than just a human combing through it. We sort of felt that, look, so we brought this thing into production, it's working, but everyone is scared to change it, right? Because now it's been so battle tested in the way it is that if you want to do a major upgrade or you want to make a bunch of changes to how the consensus works or do some optimizations, it's You're
describing every entrenched infrastructure in the history of mankind, right?
Exactly.
Oh, we haven't replaced this back-end system for processing stock since the 1960s because it works.
Yeah,
it works.
Yeah, it's written in COBOL, and we'll never change it again.
Oh man, yeah. You're gonna love it. But you walked into that one. COBOL is a running joke on this podcast, and to the point I'm gonna get t-shirts printed at some point. But
I'll take one.
It is totally written in COBOL. It'll just say now hiring COBOL planners under the age of 70. So COBOL coders under the age of 70. It's too funny for words. So I mean that's the same underlying problem everybody has. So you encountered the same thing. Hey, this shit works, but if I touch it, it might not. So you're trying to solve that problem.
So that's right. So it's an especially hairy problem for distributed systems where there's a lot of concurrency and a lot of different ways execution could happen. You have this explosive state space of possible outcomes, and you can't reason through it all just with your head, right? And so what we wanted to do, and sort of the founding of Informal Systems, was really around bringing verifiability to distributed systems, right? So that you could actually, using tools, and we're developing our own tools and really pushing the boundary on formal verification for distributed systems so that you can formally verify the protocols and hopefully, it pull it off, or at least you can do better at verifying the actual code itself. So this is different than the verification that happens for Ethereum smart contracts, right? Because those contracts, they're sequential programs, right? So they operate in order and there's no races. You don't have concurrency. It's just a single contract. And that alone is a hard problem. And there's a lot of people doing, really good work on actually being able to solve it and solve it in industrial form so that, can actually secure real funds and so on. But for these distributed systems, like these consensus protocols, and especially ones that have to tolerate arbitrary kinds of behavior. So not only can a computer crash, but a computer can actually behave maliciously and try to lie and so on. The size of the state space is explosive. And so you need a different kind of tooling. And so that's really where we're focusing. And a lot of the research we do and the engineers that are working on this are working on specifically that problem of formally verifying consensus protocols in this kind of adversarial environment where you have multiple actors, you can't trust any of them, crash failures, you can have what are called Byzantine failures where people can behave arbitrarily or maliciously and
Mm-hmm.
so on. And yet you still need to get strong guarantees out of your protocols and out of your software. And how can you do that in a verifiable way? And so Informal Systems is really about building out those tools and those processes to actually build robust, verifiable distributed systems. And we're starting with the Cosmos technology. So focusing on the Tendermint protocols, the Cosmos protocols, the interoperability protocols, developing formal specifications of them, verifying those specifications that they actually satisfy the properties we want them to satisfy, and then trying to bridge the gap between the specifications and the real code to show that not only are the protocols correct on paper, the implementations of them are also correct, or we believe they're correct for these reasons, or so on. Just really strengthening the guarantees you can get out of that distributed systems software.
Good. So, I mean, it's, you move with the value chain. You created the foundation. Now you're creating the mechanism for basically allowing you to trust your own code. What's next?
Well, that's a long project. So we have to, we're doing that, and there's many stops along the way, but we are developing tools for it and model checkers to basically expand the scope of things that can be formally verified. So formal verification is still very much in its infancy, especially for these distributed systems protocols. And what we want to do is really commoditize it, right? So we know there are groups at NASA, we know there are groups at AWS that are doing this kind of work. And some of it they keep close to the chest, right? They're like, look, this is part of how we make sure that our infrastructure is robust and available. And, we'll publish a little bit about it, but we don't need to say too much. And we're certainly not offering this as a service to other people, right? And what we want to do is really commoditize that expertise and that quality, and essentially say, look, everyone out there is building a distributed system now. Pretty much every new modern internet application is in some way a distributed system. More and more people are using consensus protocols like Raft, or like, new blockchain protocols and so on. And they're making changes to them and variations. And it's very difficult to know, did the change I make, is it still correct? Is the protocol still safe? Is it still live? Does this code change really still satisfy it? And we want to make the tools available to anyone who's building those kinds of systems and asking those kinds of questions. We want to make those tools available for them to actually be able to check and really commoditize this kind of formal verification capacity, which until now, and even still, was very much like exclusive and confined to critical systems and life support systems and spaceships and so on, very expensive things where something goes wrong that can cost millions or billions of dollars. But the reality is today, more and more distributed systems are becoming so entrenched in our civilization that something going wrong could cost millions or billions of dollars, even if it's not like carrying, someone into outer space or driving a car or whatever. So that's part of it. The other part of Informal Systems' mission is to bring that apply that exact same philosophy to organizations. So in the same way that it's difficult to build distributed system software and know that it's correct and know that it complies with the rules of your protocol, it's very difficult to build a company, an organization, especially a distributed one, that is in a valid state where all the contracts are organized, where your cap table is in the right state, all your bookkeeping is done and up to date, and everything's in compliance with the rules. And it's like hard to know who to ask, like even the simple question, like what state is my corporation in? Right? There's so many different tools and proprietary things you have to pull together. And
it even goes beyond that. When you look at what legislation in the U.S. imposes upon publicly traded corporations through Helms-Burton, like it's, there's a reason why the number of publicly traded companies has been decreasing over the years, because the cost of compliance just went through the roof, right? So, I've had people talk about, they may look to go public. I'm like, at your size, you're not. Like you're gonna blow like 25% of your profit on compliance alone, right? Yeah. So there's a dire need to solve some of the problems we're seeing that are facing the private-public split just based off reducing compliance. And I think, there's a number of ways blockchain can inform that kind of compliance audit at every step of the chain to ensure that at any point, you're fully fine. So interesting. I was going to ask you about, before you went into this rant, I was going to ask you about use cases you're seeing start to creep up, but you went into a lengthy one, including things like NASA. So,
I would say, so we're actually looking, so first thing, one is related to that public-private thing. I think that's spot on. I've kind of come to the conclusion that every private corporation on the planet is invalid. Like if you tried to compile it, if you had like a company compiler and you tried to compile your company, it would throw errors, like almost certainly. And that's probably why, more and more companies are staying private longer, right? But the reality is there is so much low-hanging fruit that is independent of blockchain. So this push to bring verifiability to companies, blockchains are a stage further down the road. There is so much we have to do pre-blockchain, before even talking about blockchain, just to use common open standards for contracts, for bookkeeping, for HR, for cap tables, like all these things. Forget about the blockchain. Like, people are very quick to get caught up with the blockchain stuff and put it all on the blockchain to solve all our problems. Like, no. Like, we have a lot of just ground level standards work to do on making this stuff open and accessible. I mean, there's all these new products launching and proprietary services launching that are sort of addressing parts of this, but they're all proprietary, right? And they don't interoperate very well. And they're not, if you're a developer entrepreneur, which is a growing demographic of entrepreneur that's comfortable with the command line, that can write code, and you want really to be able to run your company and manage your company the way you run and manage your software from the command line, using version control with continuous integration that checks if what you're doing is correct, ways you can roll it back if you make a mistake. Like, none of that is available in a company operator, and it's all independent of blockchain, and so that's what we want.
Excellent. So this has been fun. I haven't had a good blockchain conversation in a while. So before we wrap up, there's 3 questions I ask everybody. The first one is, if you had one wish for something you can change in your company or the systems as a whole or the world as a whole, what would it be?
The systems as a whole, the world as a whole. The one thing I want to change, well, there's a lot of oppression that's systemic and sort of that we take for granted, and that's sort of built in. And, this is a lot of people are talking about this now with everything that's going on in the protests in the States. And I don't know that there's one quick, easy way we can fix this. I know there's not, and it just takes a lot of work from everyone. But that seems to be a major thing that a lot of people are suffering from, and a lot of opportunity is restricted because of it. And so the more we can do about that, the more we can talk about that and surface that, I think the better. Fantastic.
Agreed. It's an interesting time to be having these conversations. We record these well in advance, but we're doing this right in the middle of all the George Floyd protests. So it's important to keep that in mind. Yeah. What has been the biggest challenge in getting either Cosmos or Informal Systems to where it is today?
The biggest challenge, I mean, a lot of the problems we're working on are very, very hard, and they require a lot of thought and a lot of context, and they cross a lot of boundaries. And so building up that context and then reasoning about things and reasoning about correctness, and then deploying these kinds of very complex software and protocols across a wide number of stakeholders it's a tremendous ongoing challenge to really establish a decentralized ownership structure and sort of governance structure. And Cosmos seems to be really experimenting with a lot of interesting things on that front. The development capacity is very decentralized across a number of companies that are forced to collaborate both across interfaces between software, but also within software. And so coordinating that and everyone aligned on like how the protocols need to evolve and so on is super challenging, but also super fun and exciting, and exploring new ways for groups of humans to kind of collaborate together on open source software and decentralized networks, which is really what it's all about.
Excellent. And the last question I have for you is, what excites you the most about what it is you're working on and keeps you getting up in the morning to fight the good fight and carry on?
A more accessible future for everyone and a more sustainable future. Essentially, the goals here are really to enable local sovereignty and local economies and localism as a kind of general approach to building and maintaining our civilization. And I believe that the technology we're working on, as much as we stay in this narrow tunnel sometimes of particular small crypto-focused problems, we're really hoping that this technology can start to be deployed to actually help real people and real communities sort of take ownership over their own lives and build systems that better represent them and their values, and not have to shout at the world constantly that their lives matter. And of course, your lives matter, Black lives matter, all oppressed people's lives matter, and they should have systems that better represent them. And I don't want to pretend that, Bitcoin or blockchains are this magical solution. There's obviously a lot of work to do, but certainly building infrastructure that reflects people's values and isn't owned by single institutions, I think can go a long way towards that. So I'm hoping.
Well, it's interesting. I had a conversation prior to this, another podcast episode where I'm not sure when it's going to air in relation to this, but it was specifically talking about the lack of female and people of color minority basically visibility or representation within VC-funded companies. And, I told the story of how when I first started the podcast, I was hoping to have that addressed and try to keep some sort of balance. And I had to give up because the number of people who fit that demographic was so small that I couldn't fill the content schedule with it. And I realized that, it's the old argument, you can't, good luck getting a diverse set from a undiverse pool. But the bigger issue is that what I am seeing with it is the end result of any number of tiny injustices compounded over time. So while it may sound a little bit like, you're going to solve the world's racial issues and all this other stuff with blockchain, are you kidding me? Yeah. No, you're not. But you're going to solve a lot of more bias subsystems that impair people in those situations from achieving what they can simply because the previous system is inherently biased. And again, it's not about being racist or inherently biased in that regard. It's just we all have our own preconceived notions of what something looks like, what something is, and it's hard to get past just natural personal biases. And if you want to argue that, just take a look at the, it's not about bias, but take a look at the work of, Rich Kahneman Tversky and just unlocking the psychology of behavioral finance. And even, Kahneman still says I've studied this for years. I still can't fix my problems, right? We can study racial issues all we can, but sooner or later, there's subconsciously or subconsciously, it's going to impact the way you think of things. So yeah, anyway, that was my rant about
Yeah.
how something as abstract as crypto can help solve the world's problems. So fantastic.
Maybe. I mean, it can look what I think what it can do.
Part of the mosaic.
It can't really hurt. It can't really fix people or I think outright solve the world's problems, like we're saying. But it can help to build more open, transparent, accountable systems, and that'll go a long way, I think, to helping resolve some of the systemic biases and oppression. Yeah.
Exactly. It's death by 1,000 cuts. We start getting those 1,000 cuts down to fewer and fewer, and the outcomes start getting a lot better. Thank you so much for taking the time. This is greatly appreciated. It's been fascinating. Glad to see you guys like you are working on stuff like this, and keep it up.
Sounds good. Thanks so much.
Take care. So that was my interview with Ethan Buckman of Cosmos and Informal Systems. I hope you enjoyed that. And as always, if you did, please leave a review on iTunes, Stitcher, whatever you get your podcast, because it does help people find us. Until next time, take care.
This podcast was brought to you by Woodgate Financial, an award-winning financial planning firm catering to high net worth individuals and their families. To learn more, go to woodgate.com. You can subscribe to this podcast on iTunes, Stitcher, and Google Play, or find more episodes at Jason